Welcome to Communication Performance. This is the inaugural video for this channel, the first video on this channel. On this channel, we're going to discuss banking. We're going to discuss banking payment processes and procedure. We're going to discuss what is money. We're also going to discuss the different instruments we can utilize to make payments and to discharge debt obligations. We're going to discuss bank laws, rules, and regulations. We're going to discuss general laws, rules, and regulations as it relates to different fields of law such as traffic, civil, criminal, etc. And we're also going to discuss history because a lot of times history is the precursor to laws being enacted or the motivation for individuals to lobby the legislature to enact certain laws. So we're going to talk about history as being the backdrop of those laws that we discuss on this channel. We're going to discuss case law, court cases on this channel. We're also going to discuss contracts. Contracts are very important. I believe that contracts impact every aspect of our lives, and a lot of you probably would agree because a lot of you are bound by contracts now as far as making payments on certain debt obligations, whether it's a mortgage, car loan, student loan, etc. And I'm glad I said student loan because that's the other thing that we're going to discuss on here, and that's going to be a major topic on this channel. Loans, but in general, we're going to discuss loans, but more specifically, we're going to discuss student loans and the laws that we see that the laws that we see that can actually help the student population that they're not taking advantage of and that they don't understand. So we're going to dissect those laws to help individuals that are students, and hopefully we're able to give them some information to help them decrease their costs for college or university. We're going to discuss math on this channel. The math is going to be tied to the banking system that we've developed. It's also going to be tied to the accounting system that we've developed, and it's also tied to the quantum linguistic system that we've developed. And those systems are tied to what I mentioned before as far as our discussion of banking and the different types of instruments that we can use to make payments or discharge debt obligations. We're going to talk about linguistics on this channel. Linguistics is very important because language is the foundation of civilization or a society. So if you're thinking, you come up with any type of scientific breakthrough, research, whatever it is, I think that language is important, and because it is the final destination of our thought process, other than speech, language, I believe language is the everything theorem, right? So it is the foundation of every civilization or society. You can actually tell the type of society you're analyzing based off of the language, right? Not so much the technology, but more so the human interaction and how we treat each other, right? So we're also going to discuss the possibilities, and that's going to be, other than linguistics, which the channel is going to be centered around, and everything that we do is going to be pivot from linguistics generally, but possibilities is going to be the other pillar that we pivot from, right? So we're going to spring from the status quo of what is already, right? And we're going to spring from our programming that we've been taught in grade school, high school, and college, and the advertising and the propaganda that's been conditioned into us, right? So with thinking about possibilities, we're going to be chasing facts, all right? Empirical data. We're going to be chasing perfection in the sense of correctness and being correct. So if we say something on this channel, or someone says something on this channel, whether it's a guest or one of us say something on this channel that somebody out there that don't agree with or they think is wrong, we encourage you to correct us, because we want to be correct. We're not interested in being, well, we don't know everything, so I'll say that. We want, our goal or our objective is to be correct. So we welcome any type of criticism or correctness, but you have to be able to back up your position with some type of empirical data, verifiable evidence or proof, and we want you to be able to diagram that data and evidence, not just give us a sermon or lecture, right? Unless that lecture or sermon is tied to you diagramming that evidence and tying the evidence into your lecture, right? So we welcome any empirical evidence that challenges our position. As a matter of fact, we love that. That's what we want, because we want to be correct, right? So the motto for this channel, as I said, that everything is going to spring from linguistics, the motto for this channel is, we correct contracts written by attorneys. Bold statement, but we're going to back it up. So this channel is going to do a lot of analysis, and we're going to start this first video by doing an analysis of a math problem that's caused a lot of controversy over the internet. And this math problem was brought out by Terrence Howard, and a lot of you that's familiar or in the know already understand or know what math problem I'm talking about. The math problem I'm talking about is 1 times 1 equals 2. We believe that math problem is correct, and we believe, or I believe, let me speak for myself, 1 times 1 equals 1 is not correct. So we're going to analyze 1 times 1 equals 2. But before we can analyze 1 times 1 equals 2, first we have to analyze 1 times 1 equals 1. And by analyzing 1 times 1 equals 1, we're going to prove 1 times 1 equals 2 is correct. So we're going to start our analysis by creating certain categories. All right, so that's going to be first position. It's going to be second position. And this is going to be conclusion. So 1 times 1 equals 1. All right, so in school, they give us a rationale for the left side of this equation, right? 1 times 1 equals 1. On the left side of the equation, they give us a rationale on why the answer or the conclusion is 1. So So the rationalization that they give us is 1 is 1 1, right? And they say that 1 1 is the rationalization, and the logic is 1, right? So they're saying that there is 1 1, or there is 1 1 equals 1. That's the rationalization, because they said everybody knows that 1 1, and this is what this is saying, right? But we don't agree with that, but we're going to diagram it out, and you can make up your own mind. So they're saying the rationale is 1 1. And what is this really saying? So the first one, which is the first position, is the counting or the numeration telling us the value of the second position. So the first position is the counting, telling us the value of the second position, right? So we get the value as the conclusion. So the counting or the numeration of the first position is telling us that it's 1 as a descriptive, and it's describing or counting or giving us the numeration of the second position or the second one as the value of the second position or the second one. So that value equals 1, equals the value on as far as the conclusion, or the value, which is the logic, right? Because you have the rationale on the left side of the equal sign, which is 1 1, right? And it's telling us that the counting or the numeration of the first position or the first one is 1, describing the value of the second position or the second one as 1. Then it says equal, which is the conclusion on the right side of the balance sheet, on the right side of the equal sign, which is the logic, right? So you have the rationale equal logic, right? So here the numeration of the value equals value, right? Just like 1 1 equals 1, right? So what is the first position saying, or the first one saying? It is saying that it is an adjective from a linguistic perspective, right? From a linguistic perspective, it is saying that it is an adjective. Why do we say that? Because it is descriptive or describing the second position, or the first one is describing the value of the second one, right? So the second position becomes a fact because the first position is the adjective describing the fact, or rather, it is the noun, rather. Okay? So, I said linguistics, but more specifically, what we're doing now is syntax based off of the rationalization of 1, which we're told explains the left side of the equal side of the equation, 1 times 1 equals 1, right? And I'm sure a lot of you remember that in grade school or high school. So we have an adjective, right? So as far as syntax is concerned, to make an adjective, you first have to have 2 nouns, right? You have to have 2 nouns side by side before you can make an adjective. So if you have 2 nouns side by side, the first noun becomes the adjective, which in this case is the first position, which in this case is also the first one, because the first one is descriptive of the second one, or the first one, which is the first position, is descriptive of the second one, the second position. So you have 2 nouns beside each other, so the first noun becomes the adjective and the second noun becomes the fact. So you have the adjective describing the fact. Just up here, you have the rationalization of 1. The first one is describing the second one, or the value of the second one. The numeration is describing the value. The numeration of the first one is describing the value of the second one, right? Or the first position is describing the value in the second position. Or the first position of 1 is an adjective because it's 1. The first position is an adjective describing the value of this, or the fact of the second position, right? And this is a fact, because if you have 2 nouns beside each other, you got an adjective describing a noun, and the noun is a fact, so it still becomes a fact. Of course, we could have put a noun here, right? So first position from a linguistic, or rather syntax position, is an adjective describing a fact, right? And the fact is a noun, right? So here you have an adjective because it's the first position, or the first one, based on the rationalization that we're told, is describing the second one, right? Or telling us what the numeration is telling us the value. The numeration of the first one is telling us the value of the second one, right? And then we get our logic, which is the conclusion or the answer, right? So if you just have an adjective here in the first position, now we jump into physics. Now we're going to say that, and we're going to make some abbreviations, right? We're going to say that, let's see here. So L equals light, and then M equals mass, and E equals energy. And then MO equals motion. Actually, we're going to make this MA. So crooked M. So we're going to make this MA. That don't look much better. Okay, there you go. So L equals light, Ma equals mass, E equals energy, Mo equals motion. So under the first position, since we have a 1, right, which is the rationalization under the first position, but under the first position, as far as the rationalization, the 1 is a numeration or accounting for the second position. So the second position becomes an adjective, and the adjective, since it's an adjective, we're going to say from a physics perspective, right, we're going to say it has no light, and we're just going to use L, right? Maybe we can write it out. No, we just use L. So it has no light and no mass, right? From a physics perspective, the second position, or the second one, the rationale is 1, right? 1, 1. It has value because the first position is numeration of its value, telling us the counting, or telling us the value in the second position. We know it's a noun, it is a fact, and since it's a fact, it has light, and it has, maybe I could write it out. Okay, so no light or mass. Here it has light and mass. Right, so since the first position, or the first one, is a numeration to let us know the value in the second position, and since the first position is an adjective describing the fact in the second position, or the second one, then it has no light nor mass, right? And if it has no light or mass, then there is no motion. And if there's no motion, then there's no energy. And that is under the first position, right? Or the first one, which is the adjective or numeration giving us the value in the second position, or the adjective in the first position describing the fact in the second position. So since we have light and mass in the second position, then we have motion. And if we have motion, then we have energy. So we can get rid of this. So if we have light and mass, right, in the second position, we're going to have light and mass as our logic. And if we have motion, although we have no motion in the first position, but if we have motion in the second position, we're going to have oscillation or motion for our logic based on the second position. And if we have energy, then we are obeying the law of conservation of energy. We are obeying the law of conservation of energy. Right? We have energy. So, although we have no energy under the first position for the first one, we have energy for the second one under the second position, right? So if based on the rationale, if we say we can say this. We can say everything is really happening under the second position, or happening with the second one, right? So if everything is happening with the second one, what if we say this? If we say 1 times 1 equals 1, and the rationale over here says 1, 1, let me write that better. And the rationale says 1, 1 equals 1, right? Rationalization, right? This is rationalization, and this is our logic, right? So if we say 1, 1 equals 1, isn't it the same if we just say 1 equals 1? Isn't that the same? These two are synonyms, right? They're synonyms. They're the same, right? Because based off of the rationalization, you're just basically saying this: 1 equals 1. 1, 1 equals 1 is the same as 1 equals 1, or 1 equate to 1. 1 equate to 1. It's the same thing. So there's a couple of issues here. So if we're saying that this is a value, if we're saying that the first one is a value, then it violates the law of conservation of energy, because this value is not accounted for on the right side of the equal sign, right? And if we're obeying the law of conservation of energy, or what I would say that it's actually it's actually God's principle of the law of conservation of energy, because conservation of energy, such as resurrection, first death, second death, everlasting life, all of that transference of energy is prevalent throughout the Bible. And we can say that if we're going to say that energy cannot be created nor destroyed, then we have to give credit as far as the law of conservation of energy to the Creator, because in the beginning, John 1 verse 1, all things were created by the Most High, And if we know that to be true and understand that to be true, then we have to give praises to the Most High. All praises to the Most High, right? So although I'm going to rest as far as the concept of the law of conservation of energy from a scientific perspective, I'm going to rest my empirical proof from that perspective based off of God's principle of the law of conservation of energy that's prevalent throughout the Bible. But, we can also put Newton's, law of conservation of energy underneath the principle of God's law of resurrection, first death, second death, everlasting life, which is probably where Newton got it from. I don't know, but we have to give credit to the Most High because the Most High created it. And once it was created, once the Word became flesh, then at that point, energy couldn't be created nor destroyed, right? And that's just from that particular saying is just from a human perspective, because God could do whatever he wants, right? But let's stick to the mundane things of the human being and stick to the law of conservation of energy. But as I said, I give credit to the Most High for that, and that's where I rest my proof on, because let God be true. Let God be true, and every man a liar. That's what I say. So, getting back to this, so we prove right here that, or rather over here, if individuals are saying that this is a value and this is a value, which the rationale doesn't equate to that, but just for argument's sake, if they're saying that this is a value as this is a value, then I'm saying it violates the law of conservation of energy, because this value or this energy is not accounted for on the right side of the equal sign, right? The rationalization should equal the logic. And if your rationale or your rationalization is you have one value here and one value here, then the logic should be balanced over here. Your rationale should be balanced over here when it comes to your logic or your conclusion or your answer. And it is not. This is an unbalanced equation. But based on the rationale, right? So let's get to that was the first thing. If we're saying that's a value, and we have two values on the left side of the equal sign, then we have to admit that it violates the law of conservation of energy, because only the second, or only one energy unit, let's use that term, right? Only one energy unit transferred over. So what happened to this? What happened to this unit, right? What happened to this value? No one's explained that. And I would love for somebody to diagram some empirical data, some empirical evidence, proof, right? And tie that into their lecture or sermon that I'm pretty sure that they would add to this. So that's one. The other thing is, since if we're going by the rationalization, right, we're saying it's just 1, 1. But what we're really saying, if we're saying is 1, 1, then we only have one value on the left side of the equal sign. And if we only have one value on the left side of the equal sign, then what we're really doing is just equating 1 equals 1. Right? We're just equating it. And this, based off of the rationale, this would be superfluous. That's superfluous. That's extra and unnecessary. Right? Based off of the rationale. Because we're saying it's 1, 1 equals 1. Right? The first position is an adjective or counting or numeration telling us the value of the second position. Right? Telling us the value of the second position or the second one. Or we could say it's an adjective describing the fact, right? This is the adjective and this is the fact. We're saying it's 1, 1 equals 1. Otherwise, this particular problem, 1 times 1 equals 1, don't fit the definition of the word multiplication. The word multiplication means to increase in number. So if we're not increasing in number by using these two values, then we don't have a multiplication. Based on the definition, we have a static formulation. Not an equation, we have a static formulation, right? Because there's no increase in numbers, so this is superfluous, unnecessary, and don't need to be there. And what we're really saying is 1, 1, right? Isn't that 1, 1? Right? So if it's 1 times 1 equals 1, and the rationale is 1, let's do this. The rationale is 1, 1, right? And this value is not being accounted for, or this rationale is not being accounted for in the logic, or this value is not being accounted for on the right side of the equal sign, then that is unnecessary. And what we're really saying when we say 1, 1, we're really saying that 1 equate to 1. 1 equate to 1. And that's the equation that this rationale, or what they taught us in school, is really saying, because they've disregarded the first one or the first position. And if you disregard the first one or the first position and use it as an adjective or numeration to tell you what the value here is, you're using it as an adjective, and you're coloring, right? You're using it as an adjective, coloring this fact, right? Or you're using it to shade or adjust the fact. But whether you're trying to change the fact the fact remains that you don't have a value on the first in the first position. So you can't increase in number. You can't bring these two if this is not a value here, and this proves that one of these is not a value, more specifically based off of the rationalization of 1, 1, this is saying, the rationalization is saying this is not a value. It's a descriptive of this, letting us know the value here. This description is letting us know the value here. So if you say 1 times 1 equals 1, then if you don't bring this value over, or you use this value to increase in number by bringing these two together, right? By bringing these two together and increase in number, then you violate the laws of physics, and this is not necessary because you're not increasing in number. You have a static formulation, right? This is a static formulation. One times 1 equals 1 is a static formulation. It's not an equation based off of, it's not a multiplication equation based off of the definition of what multiplication is, which means to increase in number. So you got to combine these two, which transfer the energy over here, right? And if you don't do that, then this is unnecessary, and you are basically just equating 1 equals 1, right? Which is the same as 1 times 1 equals 1, because your rationale is 1, 1, or 1, 1. And it proves that's what you're saying, 1, 1, because your answer is 1. So that proves your rationalization is matching the wrong answer. Okay, so we can say that the rationalization is wrong. No, we can say that your rationalization matches the answer, because you're saying you just have 1, 1, right? And that's the same as if you say this. It's the same as you say 1, 1 equals 1. And you say 2, 1 equals, and 3, 1 equals 4, 1 equals, right? So here you got 1, which is the descriptive of the first position, the descriptive of the second position, right? And so that's your rationale, and your logic is 1. Your rationale is 2, 1, and your logic is 2 1s, right? Your logic is 3, 1, so you have 3 1s. Description or adjective or the counting or numeration for the value in the second position. So here you have 4 1, so you have 1, 2, 3, 4 1s, right? So when you say 1 times 1 equals 1, and then your rationale is 1, 1, you're just saying 1, 1 equals 1, right? But what are you really saying? Because this is a description, it is not necessary. It has no, it's superfluous, right? Because based on the rationale, you're not even multiplying. Based on the answer, you're not multiplying because you're not increasing in number, right? If this was a value and this was a value, you would have to increase it in number. But based on your rationale of 1, 1, you're not increasing in number. This is a descriptive of this, right? This is describing the value here. So the first position or the first one is describing the value in the second position, or it's describing the value of the second one, right? So you don't need this because you're not multiplying. You're not increasing in number. You just have a static formulation, right? And that's what you have. 1 equate to 1. That is the equation that you're saying based off of the rationale of 1, 1 equal the logic of 1. So, I think that we've proven that 1 times 1 is wrong, right? And so let's give you some more proof. All right. So let's do some common sense thinking. So, and we're going to keep it simple, right? Because simplicity is the key. Simplicity is genius, right? So if you have one man, times one man, well, no diddy. If you have one man times one woman, that equals 2 human beings. All right. If you got one, say you have one car times one car, that equals 2 cars. If you got, and Terrence Howard gave this, I believe he gave this example, these last two examples. Although, well, first of all, let me say that Terrence Howard book is a phenomenal book. Everybody needs to read that book. And I can see why a lot of scientists and people in academia got upset at Terrence Howard, because he basically bodies a lot of scientific perspective. And I would just say that he bodies the entire scientific community, right? I didn't say he eviscerated them. I say he bodies them, right? And proved that a lot of scientific theories that they had or perspective is wrong, right? So if you get a chance to read his book, you can go to his website. You can just search Terrence Howard website, and his site should come up, and you'll be able to read his book. You may be able to download it, but if I was you, I would get a copy of that. I'm not sure if it's for sale. I don't know. I got it from his website. I think it's one of the greatest. It's a book written by one of the greatest minds. It is intellectually awesome, but simple, where you don't have to be a scientist to understand it. But he makes the complex simple. And that's a mark of a genius. And I think that people don't want to give him credit for what he's done. But I'm a little bit confused about his last performance on the Joe Rogan show, when he said that 1 times 1 equals 2 is a metaphor. I don't understand that, because his book proves completely otherwise. Common sense proves completely otherwise. Maybe the powers that be got to him, and you know how that goes. But I think it's a phenomenal book, and I think it's one of the greatest books ever written. That's just me. But read it if you get a chance to. I think you'll enjoy it. So, one of the easiest examples in the book, but I think it's one of the most profound examples that proves 1 times 1 equals 1 is wrong. Right? It proves 1 times 1 is wrong. It proves that 1 times 1 equals 2 is correct, is this example. Well, first before we get into that example, I like this example. When Terrence Howard was at, I believe it was Harvard University, I could be mistaken, but it was one of those Ivy League colleges or universities. When he was given his analysis, and then he was taking questions, and the video showed this young lady that was highly upset about his finding of 1 times 1 equals 2. She came out and said, everybody knows that 1 laptop times 1 laptop equals 1 laptop. Now, before she got to her answer of 1 laptop, she paused for like maybe a half a second, and I could be wrong, but I'm thinking when she said 1 laptop times 1 laptop, before she said the answer, something said, does that sound right? But maybe it was ego or cognitive dissonance said, go ahead and say it. Just say 1 laptop as the answer. And she said it. But is that correct? 1 laptop times 1 laptop, does that equal 1 laptop? I don't think so. Right? And saying it is one thing, but diagramming it in where you can actually see it is something different, right? So we have 1 laptop times 1 laptop equals 1 laptop. Is that correct? If this is correct, then there's a problem, because somebody stole this laptop. If this was her property, somebody would have stolen her laptop. I would never put her in charge of my property, because somebody would steal my property, or she would leave it somewhere and swear to me that I only gave her 1 laptop. 1 laptop times 1 laptop cannot equal 1 laptop, because this means that somebody needs to explain what happened to this laptop. Right? So, her equation is totally flawed and wrong. And I believe internally something told her it was wrong. But, I guess she had to keep up with the Joneses. All right, so if you got one laptop and you got light, L stands for light, M stands for mass, and you got light and mass, then you're going to have light and mass, and that light and mass is going to equate to 2 laptops. Because if you give somebody a laptop, come back and give them another laptop and say, okay, 2 hours later you say, I want the laptops that I gave you. They're going to have to give you 2 laptops. How can they just give you 1 laptop? That makes no sense, right? All right. Now, this is a good proof, but I think the most profound proof that proves Terrence Howard, or proves 1 times 1 equals 2, is this equation. $1. Oh, we can get rid of this. Okay, so let's prove this with a simple equation, right? Simplicity is the key. Simplicity is genius, because we are taking the complex and making it simple. Okay, so $1 times $1 equals $1. Is that correct? No, that's not correct. That can't be correct, right? Because you got $1 here and $1 there. And if you're increasing the number and bringing both values, or you're accounted for both values, right, you're going to have to say it equals $2. Ooh, that's ugly too. All right, you're going to have to say it equals $2. All right, so if you have $1 times $1, it equals $2. If you go to the bank and you deposit $1, 5 hours later you come back, deposit another $1, and then the next day you come back and say, okay, I'm going to withdraw both dollars, or you come back and say, I'm going to withdraw my money. The bank is going to have to give you $2. If they give you $1, that means that somebody has embezzled your money. And if they give you $1 and say, you only gave us $1, that means somebody embezzled this. Right? Embezzle one of your dollars. Is that correct? Of course it's correct. Nobody is going to say, I gave the bank $1 at 9 o'clock, came back and gave them another $1 at 12 o'clock, and then when I went to withdraw my money, they only gave me $1. Nobody's going to... Come on. If you say that $1 times $1 equals $1, then, I hope you don't work in accounting. It has to equal $2. And that's the most common sense proof or evidence we can give to show that 1 times 1 equals 2. I mean, who can argue against that? I think it's pretty difficult. I would love for somebody to diagram an opposing position and give based off of $1 times $1 equals $2, right? Which is the same as 1 times 1 equals 2. Give an opposing argument and empirical evidence and diagram that evidence and tie it into the lecture or the reasoning or the rationalization and the logic of their position and prove that this is wrong. I think it would be pretty difficult for somebody to do that. All right. So let's go ahead and work through one more set of proof. Right? So you got 1 times 1 equals 1. And then you have 1 times 1 equals 2. All right. So if we got 1 times 1 equals 2, you know what? Let's bring this a little closer so we can bring this over a little bit more. So we can stay within the frame. Okay. So let's deal with 1 times 1 equals 2. So 1 times 1 equals 2. What is this telling us? It's telling us that this is a balanced equation. It's telling us that this is a multiplication equation because you have two values that increase in number. You have the rationalization of 1 times 1 increasing in number equals the logic of 2. Right? So you got 2 divided by 1 equals 1. What is this telling us? It's telling us that you have 2 1s, which equals this 2. Because if you have the definition of division is separating into 2 or more parts. So you have a 2 and you're dividing it by 1, right? And you separated it into 2 parts. You have a 1 here and a 1 there, right? And that equals 2. Right? So let's do 2 minus 1 equals 1. Same thing. It proves that you have two 1s right here, which proves that if you have 2 1s, what does it equal? It equals 2. Right? So if multiplication is the inverse, if multiplication is the exaggeration of addition, right? They're on the same root and generally have to follow the same practice or pattern, right? They have the same genetic, right? You're increasing in number here. Right? You're increasing in number here, and you're increasing in number here. Right? And you're transferring the energy from the left side of the equal sign to the right side of the equal sign when you've combined them. And so your rationalization matches your logic. And this is an equation, right? So if they're on the same or from the same root, they must generally follow the same process, right? Which is increasing in number or adding or combining the values on the left side of the equal sign to form or transfer the energy to the right side of the equal sign. All right? So we've proven that 1 times 1 is correct. Now let's look at 1 times 1 equals 1. Right? So let's look at it from, let's divide, right? 1 divided by 1 equals, well, we have a problem because the definition of division means to separate into 2 or more parts. You can't separate a number by itself. So this can't be done. You can't divide a number by itself because you have no ability to separate into 2 or more parts, right? So this is a void equation. It's unsolvable. Okay, let's try subtraction. 1 minus 1 equals 0. Well, this is a problem as well, right? Because what is this telling us? This is telling us that energy can be destroyed. Why do I say that? Because if you have a value here and a value here, you're creating and you're minus, you have the same value and you're taking one value, well, you're creating an eviscerating principle here, which equals nothing over here, right? A 0 equals no thing. And no thing is not a fact. It's void of a fact. It's void of light, mass. It's void of energy, right? Void of motion. You have nothing. So the two values, or the value here, some may argue that this is a value, right? But let's take away that argument, because some may say, okay, this is a -1. But I would say that is just a minus sign, right? If you're going to say that, then you should also attach the multiplication to the second one, right? So in any case, you're still destroying a value, right? Or you're destroying a value, which means that you're destroying energy, which violates the law of conservation of energy. So there's no such thing as a 0. It is a placeholder for a number. But we can say, based on this formulation, that there is no equation, or we can say a formulation of a number minus itself, it's not an equation, because it violates the laws of conservation of energy, because the answer would tell us that energy can be destroyed, which would go against God's principle of the law of conservation of energy in the Bible, and as well it would violate Newton's law of conservation of energy, right? So this is also a void equation. All right? This is also a void equation. So what's left? 1 plus 1 equals, well, 1 plus 1 equals 2. Huh. So if these two are from the same root, have the same genetic, because multiplication is an exaggerated form of addition, so we could say that the addition is the parent, and if the child diverge from the parent, then we could say that the child is out of order and wrong, right? This is correct, and this is wrong. That's wrong. This is wrong. This is correct. And this actually proves that. Or rather, it proves this. Right? It proves 1 times 1 . 1 times 1 equals 2 is correct. And I think that's all the proof that I need to diagram to prove my point that 1 times 1 equals 2 is correct, and 1 times 1 equals 1 is flawed and wrong. So this is the first video of this channel. Like I said, this is our first analysis. The next analysis that we're going to do is 0 times 1 and 1 times 0. And that's going to be part 2 of this video. And I think those 2 parts will close out this video series. And then we're going to jump into the topics that I like to discuss is banking, law, linguistics, so on and so forth. And those, I think, is going to be exciting. And we're going to cause a lot of disturbance. You know, we're going to do a lot of correcting, but we're going to show proof. We're going to show evidence. And we're going to show that a lot of things that we've been taught is wrong, right? And I'm going to also, I'm excited to also bring you or detail some of the aspects of the accounting system that I developed, the banking system that I've developed, and also quantum linguistics. Which is a positive language, which is different than the way that we write now, which is the language is negative, right? And we're going to get into all of that. And I think that it's going to be very beneficial to you and give you a lot of information that you can utilize in your everyday life. So please like and subscribe the video, and stay tuned for the next video. Thank you.